Yes, because I sure as heck would rather get a trip to Vegas than $10. So how many people are we picking? Three. How many options for the first spot? Second spot? Last spot? Good? Everybody on board? Good? Yes?
For this one, since you don't care what the prize is, you only care about how many prizes there are. Why does
You don't care what the price is? If you got picked, you wouldn't care whether you got the $10 gift card or the trip
I
to
mean, I
Vegas?
care if I get picked, but for the
Yeah.
number of prizes, if it's
It matters, because it matters. So we'll talk about that. So the way someone, we'll talk about that a little more when we get to the next part of it. But yeah, it matters, because is a $10 gift card the same as a Vegas trip? No. Are the outcomes the same for all three of these people? Then no. Because these three people will not get the same outcome, the same result. Here it is there, prettier. Okay. So, first of all, how do you guys feel about, is everybody solid on this?
Yes.
Because we're going to go a step further, we're going to elaborate on it, and need to be sure about this before we move on. Good? Do you guys want 30 seconds or no? 30 seconds, go.
a good way to protect that, change the numbers. Let's say instead say four door prizes awarded at a party of 150.
All right, now we're going to change it up. So now, what if order doesn't matter? So here's an example where order doesn't matter. I picked 3 chaperones for a field trip. They all are just going to be chaperones. Now, order would matter if I said, okay, I'm going to pick you and you're going to check the kids into the bus. Okay, I'm going to grab you. You're going to make sure to pass out all the lunches. I'm going to grab you and you're going to take them all on trips to the bathroom when they need to go to the bathroom. If they all have a different job, then it would matter. Do you guys think order would matter? But if you're just all chaperoning and just kind of all hanging out, then order doesn't matter. Good? So order doesn't matter. Here's 4 people: Alice, Ross, Laura, Rigo. How many ways can I just select 3 of them? And you can kind of think of it as not Alex, those 3. Not Ross, those 3. Not Laura, those 3. Not Rigo, those 3. So there's 4 different ways. Everybody on board with that part? 4 ways of selecting 3 of them. What if order did matter? What would it be then? How many spots?
4.
How many spots? 3. I always put my spots in first because it's easier for me to kind of keep track of it. If I put the little lines in there. And then how many options for the first spot? 4, and then 3, and then 2. Does everybody see where? So I would strongly urge you, draw the lines in. 3 spots, draw in 3 lines. 4 spots, draw in 4 lines. Everybody see what I'm saying, these guys here? And then your N goes here, and then just kind of move down 1 each time. Okay, now, so this would end up being 24. So I have, if order matters, it's 24. If order doesn't matter, it's 6. So here's the thing. How do I get from 24 to 4? Sorry. If order doesn't matter, it's 4. How do I get from 24 to 4? I have 24. How can I get to 4? Divide by 6. Why am I dividing by 6? That's the question. So everyone take a second with your neighbors. Try to figure out why I would want to divide by 6. So you can figure it out. Color matters. Color is important.
I think I see it. Add the 4 and the 3 and get 7 and subtract 4.
Who thinks they have an idea? Yeah.
There's 6 different combinations for the names to be in.
Yeah. So here, if you look at these 6, the red ones, they're all Alex, Ross, and Rigo in some order. But those same 3 people. When order matters, there's 6 different ones. When order doesn't matter, they're just one. Do you see what I'm saying? If order matters, then Alex, Ross, and Rigo is different than Alex, Rigo, Ross. But when order doesn't matter, they all 6 of those just count as one possibility, the one that has Alex and Ross and Rigo in it. Does that see what I'm saying? If order doesn't matter, then Alex, Ross, Rigo is the same as Alex, Rigo, Ross. Is the same as Rigo, Ross, Alex. Is the same as Ross, Alex, Rigo. So all 6 of those just count as one option, the one that has Alex, Ross, and Rigo in it, instead of 6 different ones. Same with this one, right? Order matters, then these are all 6 different ones. If not, they're just one. These are just one. These are just one. So if order matters, then there's 24 of them. But order doesn't matter. There's 1, 2, 3, 4 of them. The one without Rigo, the one without Ross, the one without Alex, the one without Laura. So why are there 6 in a group? Why are there 6 in a group? Three times 2 times 1. How many ways are there of arranging 3 people? How many options for your first spot? 3. How many options for your second spot? 2. How many options for your last spot? 1. So it's 3 factorial. So you divide by 3 factorial because there's 3 items you're picking. So combinations, the bottom line of combinations, if order doesn't matter, then it's just like a permutation. Right? If order doesn't matter, okay, if order matters, it's 4p3. If order doesn't matter, it's what we call a combination. 4 choose 3. So it's all 4 choose 3 is you add an extra step at the end. You do this regular one, and then you divide by r factorial. That's it. So it's just a regular NPR, and then you divide by r factorial. That's the easy way of doing combinations. So order matters, do the regular one. If order doesn't matter, you just have to add an extra step at the end, divide by r factorial. Number of ways of arranging our items, or ordering our items. So on your notes, I would just put down this for NCR. I'd put equals that, personally.
Do you have all these slides online?
Yes, they're on Canvas. I can show them to you now. You guys believe me?
Yes, that would be lovely.
So we are here. See, it says Board Work PDF, chapters 1 through 4. 1 through 4. Here's all of our lectures and all the notes from there. Here's last class. Oops.
Is that also where you post the, where do you post the videos?
The videos are on YouTube. So you have to get to, so this is all the stuff we did last class. To get to the videos, you have to take the link I emailed you and go to that one and then subscribe to my channel because they're not closed captioned, so I can't post them on Canvas.
Oh, you really do have it.
Well, my channel is just basically all of my videos for this class. That's it. I don't have a channel. It's just, here's all my stuff in the class if you guys want to watch it. And that's the only way of me getting it to you easily. So you subscribe to the channel, then you can go to my channel and go to my playlists, and every playlist is a lecture. Yeah.
Do you have the email?
I emailed you guys the second week of school, first week of school. But if you email me, I can email you another link. Yeah. Okay. But email me first, because I'm not going to re-email everybody, and then I email everybody else again, and then someone says, well, I need it, you know, and then I'm emailing people. Everybody is going to get like 15 emails every time someone asks for it. That's not, yeah. Okay. Here's another way of looking at it. Like I said, this is kind of what I put down for the combination permutations. If order matters, I would say start with N, multiply down our spots. If order doesn't matter, then it's just NPR divided by R factorial. So, yeah, so that's one of my students, this is how she remembers it from last semester. She said, the regular one's regular. This one, if order doesn't matter, then it's kind of like it's all chaos or chaotic if order doesn't matter. So that's how she remembers the C. That's the one that's the combinations, is the one that's kind of chaotic. Yeah. And it's really straightforward. You just, well, I'll show you. I personally would not do this. I would not do those ones. Because I think they're just more confusing than they're helpful, personally. It's up to you guys. But I don't like them. Here's a flyer type. Advertising exec has to pick 3 photographs. Order does not matter. She has a choice of 10 to start with. So how many is she picking? How many is she choosing? 3. So 3 spots, 3 lines. 1, 2, 3. Everybody on board? What's she starting with? How many does she have? 10. So 10, then 9, then 8. Now, because order doesn't matter, you have that extra step. Divide by, how many items did you pick? 3? 3 times 2 times 1. And they match up kind of, 3. There should be one of these for every one of those. So if there's 3 here, 3, 2, 1, done. Makes sense? It's super clean and really easy, I think.
So if there were more spots, then it would.
I'd have more numbers. If I had one more spot, then I'd have a 4. It'd go 4, 3, 2, 1. Yeah. So you guys do problems 6, 8, and 9 on your lab, and then we're done for the day. So do it quickly. All right, let's go over number 6 first to make sure everyone's on the right page. So here, this is not. So permutations and combinations are where you have a kind of a pool that you're picking from and you cannot reuse items. This is not that. Everybody understand that? These are like different choices you're making. That it's not where you have like a group of horses and you're just going to choose from this one pool and not reuse things. So here, you have how many choices to make?
5 choices.
Yeah, you've got exterior color, interior style, transmission, and engine. So you have 5 choices to make, 5 different lines down here. How many options for your first choice? 7. Next choice? 3. Next choice? 3 of those. Next choice? Manual transmission, manual or automatic. And last one is 4 or 6. So there's 2 of those. Everybody on board? Great. Now, the next one, club. Club has 12 members. Can you reuse items? Can someone be president and vice president? No, so it's going to be permutation or combination. Does order matter? Does it matter whether you're VP or treasurer or secretary? Yes, so order matters. One of my students described it like this. If when you pick them, you put them into certain positions, certain spots, then it's permutation, order matters. If you pick them, you just put them into a big bin and they all kind of roll around in there, like chaos, then it's a combination, order doesn't matter. So I thought that was helpful. So how many things are you picking? How many choices are you making? Four. Four things you're going to multiply. Right, vice president, treasurer, secretary. How many options for the first thing? Second one? Next one? Last one? Good? All right, and then we'll take a look at the last one. Number 9. Okay, so A. So here, 200 people are picked. You pick a number. Once your number gets picked, they can't draw that same number again. So again, it's a big pool. You're drawing from a giant pool without replacement. So the first was it's permutation or combination. The first one, does order matter? Does it matter whether you get $30 or $100?
Yes.
Yes, so order matters. How many spots are you picking? So it's going to be 3 spots. How many options for the first spot? Next spot? Last spot?
8.
Great. The next one, they all get $80. Does the order matter?
No.
No. So here, that's different. We're going to do a combination. How many spots are you picking? 3 spots again. This part's totally the same. 200, 199, 198. However, because order doesn't matter, you have the extra layer of dividing by 3 times 2 times 1. If there were 4 spots, this would be 4 times 3 times 2 times 1. Do you guys understand what I'm saying? You'd have one more spot here and you'd have one more spot there. Just make sure we're real clear on that one. So you guys realize they're all 3s. All right, have a good couple days. See you Thursday.